Good afternoon, everybody. Yeah, so I'm Alex Nichol from Arista. So yes, as Carson pointed out, previously we have done EVPN Multicast, or it was named OISM. But previously when we have done the testing, it's been within a single domain. So that's the source and receivers in the same domain. What we're going to demonstrate today is having sources and receivers not only in a different EVPN domain, but also external to the domain. So as I say, the idea here is we're going to use EVPN OISM, which is based on the RC 9625. And what that's going to allow us to do is use EVPN as a control plane, but also be able to signal multicast sources and multicast receivers, right? And the way we do that is we're going to be advertising type 6 routes, or what's termed as estimate routes, which is all defined within the RC. What we're going to do a little bit more than we did previously is have sources and receivers not only within a single domain, but have sources and receivers in a separate EVPN domain, and also sources and receivers external to the EVPN domain. So in this case, they're going to be in a PIM domain as well. So what this means is we're going to show you two types of functionality, or what's termed as gateways. So the first gateway we're going to show you is the idea with terms of PEG. So a PEG is taking a source or receiver that sits in a PIM domain and transition that PIM join to an EVPN estimate route into the EVPN domain. All right. So the gateway in this case, PIM standing for PIM being PIM to EVPN gateway, so hence the term PEG. And what you have here is you'll have, again, for redundancy, you can have multiple PEG nodes, and the elected DR will be the one responsible for sending the PIM joins and the estimate routes. So the first piece of the demo is taking receivers or sources in the PIM domain and taking them into the EVPN domain. And then the second part of the demo, and it's all in the one topology, is what's termed as an egg. So in this case now we have a source and a receiver, but in a different EVPN domain. So the source and receiver is still running OISM, but it's going to send multicast traffic between two different EVPN domains. And to do that, you have a functionality on the boxes which is called an egg. In this case, an EVPN to EVPN gateway. And the idea here is now that as you signal within one domain, the egg is going to be responsible for taking the estimate route, proxying for multiple joins for the same group, proxying those joins into a single join, and then re-advertising that estimate route into the second domain. So kind of breaking this down is what we have in the topology is three domains, right? We have on the left-hand side, we have the PIM domain. And in the PIM domain, we have a receiver and a transmitter, right? So that means it's going to be sending PIM joins, but it's also going to be transmitting multicast sources within the PIM domain. And then to connect that to the EVPN domain, we have a node, which is the PEG, which is the Arista node 125 in the demo, which is going to bring the multicast feed into the EVPN domain, in this case, a domain which is named domain A. And then to get the sources and receivers are actually in a separate EVPN domain, which is domain B. So therefore now, the PEG is going to do the PIM join, signal PIM join, then advertise an estimate route into EVPN domain A. And then the egg is going to now be responsible for taking that estimate route and then re-advertising into a second EVPN domain. So kind of illustrate what we're going to show you is, so this is the path of, I have a receiver in the PIM domain, I have interested receivers or transmitters, in the EVPN domain B. So we're going to see a PIM join coming from the PIM domain. The PEG is going to be responsible for taking that PIM join and then re-advertising an estimate route into domain A. And then the egg, whatever one, in this case, what's selected egg is the 123 node, is going to then be responsible for re-advertising that estimate route in domain A into domain B. And that means I now have a multicast state. And then the same thing in reverse. Now I have an interesting receiver, I have a source in the PIM domain, and I have an interest receiver in domain B. So in this case, the interest receiver is going to result in an estimate route in domain B. And in this case, we have an estimate route coming from the Arista box, and also another estimate route coming from the Nokia boxes, which is node 30 in this diagram. The egg in this case is going to proxy, because it's a join for the same group, the egg is now going to respond for proxying those two joins into a single estimate route and advertising that estimate route as a proxy into domain A. And then the PEG is then going to respond for taking the estimate route and sending a PIM join upstream to where the source resides. All right, so what you're seeing here is both a PEG and also an egg, right? So now we have external resources, external receivers in the PIM domain, but also external sources and receivers in a separate EVPN domain as well. Well, let's go to the demo. So what we have here, I'm going to go, first of all, I'm going to go from left to right. So I'm going to show you the setup in 134, and we'll go to 125, and then we'll look at the eggs, and eventually we'll look at 121. So you can see here in the setup, so this is the box that's running PIM. And here you can see both, I have a incoming local interface, so this is where the source is, and it's sending this traffic, and it's sending out an outgoing interface, which is this here. And at the same time, I also have interest, so this is where I'm receiving from. Okay, this is the traffic it's receiving to me in a PIM domain, and this is the traffic going out. And he's sending a join, so if I go to the peg, you can now see, first of all, you can see the fact that it's obviously running EVPN in the here. So I have neighbors with locally, and I have neighbors as well with the two egg nodes that are in the domain B. And what he's now advertising is, if I look at the routes, you see that I'm taking that PIM join, I'm locally receiving, and I'm now advertising it. This is the estimate route now advertising from the PIM domain into the domain A, the EVPN domain. And you can see also that we'll see this in a minute. This is the route, this is the estimate route being advertised from domain B into the domain A from the eggs. If I now go to the egg itself, you can see that I have basically the egg has two domains, domain A, domain B. So here I'm looking at domain B, and you can see here I'm originating the routes for the joins that are coming from the receivers in domain A. And then for the join that's coming in, or the estimate that's coming in from domain B, I'm also going to re-advertise that into the other domain, so in this case domain local. So you can see another set of estimate routes being advertised by the egg into the other domain. Which therefore means, if I again look at the IPM route table, you can see now I have two two routes. I have incoming, which is going out across the EVPN VXLAN domain. And a second route is also going out across the VXLAN domain. Right, so this is coming from domain A, going to domain B, and going from domain B, going into domain A. And then on this host actually has, if you look at it, this is actually a multi-home host. You can see this is running an ESI, and this node 121 is going to be the designated forward for the traffic. Because of the DF, it's also going to be responsible for sending the estimate route. So it's got a local receiver, it's going to receive a local join, and it's going to therefore respond for sending the estimate route. So you can see here's originating, so 121 is this node, and this is the estimate route it's sending, because it wants to receive the traffic coming from 2010, 133, 133. So it's a multicast group it wants to join. And because it said that join, he also now has an inroute. So you can see his inroute is the source he wants to join. You can see he's got an incoming interface, which is coming across the EVPN VXLAN domain, and it has an outgoing interface, which is his local VLAN. Now, because this node is actually running an ESI, it's also going to make sure it syncs its join state with its peer, which is 121, or 122, I should say, sorry. It's also going to advertise a join, what's called a join sync. So that means I've locally received a PIM and an IGMP join. I'm the DF, but I'm also going to sync that state with my peer, so he also has a local state for his IGMP group. And he does that by advertising this join sync route, which is a type 7 route in EVPN. Which therefore means if I go to the other node, which is part of the same, you can see he's part of the same ESI, but he is not, he's the non-designated forward. right? So he's not going to be sending any SMET routes. But if I go to he does, however, have a local join coming in. All right, and that local join is because he's sharing the ESI or the port channel with his peer. And because of that sync route I just seen, I'm going to actually then take that sync route and allocate the join to my local interface that's attached or associated with the ESI itself. In this case, port channel 2122. I'm going to hand it over to Mohammed, who's going to do your.
Okay.
Let me get you. Look at the Nokia node, which is what 30.
Thank you, Alex. Hi, everyone. So let's try to make some show command and configuration to verify some functionality on Nokia. So first of all, I'll show you that we have EVPN enabled. So we have two BGP enabled, one for the underlay, and the overlay we are using EVPN, and for the underlay we are using IP version 4 with Arista root reflector. Quickly, I show you the configurations that we are using here. So we have supplementary broadcast domain. So this is towards the core. This is the supplementary broadcast domain, VRF, that we are using. You see here, supplementary broadcast domain is enabled. It has the IP interface on the IP VRF. It has also a root target and configure, and also IGMB snobing is enabled as well. We have local MAC VRF, which will receive the multicast. For this one, we have IGMB snobing enabled, and this is the interface towards the CE that will receive the multicast, and it also has layer 3 interface towards the IP VRF. In the IP VRF, we have all the layer 3 interface, the gateway for the MAC VRF, and we have also PIM enabled and IGMB enabled. In the PIM, we put the interface of the supplementary broadcast domain, and also we put the local MAC VRF. If we can use source there, we can connect source there as well. And in the IGMB, we put the interface of the local MAC VRF to receive the multicast traffic. So as Alex said, once we send the IGMB join, we transfer it to SMET route. So let's see the SMET route. Route type 6, this is the SMET route. We receive the SMET route from the same domain and from the second domain as well. If you see here, you see I'm receiving from node 121 and 123. 121, this is the local node that we have in the same domain, and 123, this is the node. I receive for multicast source 133 and 121. As you can see, I have two groups. Also, I can show that I'm sending also this route as well for my group that I wanted to join. So I'm sending that to Arista. It's fine. Advertise route EVPN. So I'm advertising also route type 6. SMET route for the group that I wanted to join. This group, I'm joining this group. So some show command now for the IP VRF. Protocol BIM database. So I see I received for this group and this source address. It's incoming interface, which is the supplementary broadcast domain. It's coming in the supplementary broadcast domain. And I have two outgoing interface towards the local MAC VRF. If I make details, I can see the outgoing interface, which is 1030 and 1301. This is the local MAC VRF. In the local MAC VRF as well, I can make some show commands, multicast forwarding basis. So I see I received for this group, source and group, and I forward it to the local interface, and I forward it as well via the VXLAN as well, neighboring 121 and 123. So protocol IGMB as well, I can show some. For protocol IGMB snooping group. This is the group that I'm receiving. It's receiving on this via this interface, and this is the group. Last thing, I can make some statistic for the interface as well, the local interface. You see here also, this is the groups that I'm receiving. This is the receive V report and the forward general queries, all the stuff related for the multicast statistic if you wanted to check it. I think that was it for some show command and configuration, just to explain the functionality in prep. I hope it's okay. Thank you. Thank you.